A Chinese tech company has created a car that leaves some of the planet's most expensive hypercars behind in performance. The margin is so wide that seasoned specialists from Germany, Britain, and Italy are reviewing figures and wondering how a newcomer managed what decades of experience could not. What adds to the surprise is the vehicle's appearance. It lacks any prominent rear wing, no oversized carbon fiber addition on the back, and no aggressive front element jutting outward. From a distance, it resembles a sculpted form, as though a drop of water had been stretched into an automotive silhouette. Clean lines that achieve remarkable aerodynamics in ways standard designs rarely permit. This vehicle is the Xiaomi Vision GT. When unveiled at the 2026 Beijing Auto Show, it did more than draw crowds. It prompted veteran automotive experts to reconsider core assumptions about generating stability at high speeds. To grasp its importance, we should first consider the persistent challenge it confronts, a problem embedded in automotive engineering for generations. The feature that shaped performance for decades. For many years, the rear wing stood as the standard answer to a recurring issue. As vehicles reach higher speeds, airflow over the body tends to produce lift, reducing tire contact with the road. Diminished grip at elevated velocities means losing control. The rear wing counters this by creating the opposite of an aircraft wing's effect. Rather than upward force, it presses the rear downward. This boosts traction, enabling faster cornering without sliding. The solution was straightforward and effective, yet it came with notable drawbacks. Every increase in downward pressure also heightens resistance to the air. This drag slows the vehicle and caps top speed. Engineers long struggled to balance these conflicting forces. Racing organizations dedicate teams to optimizing airflow, running extensive wind tunnel sessions to gain small edges in lap times. The difference between competitive and championship machines often hinges on subtle refinements in how air moves across surfaces. At the core remains the same compromise. Greater downward force typically brings greater resistance. Leading European hypercars today achieve what specialists term an aerodynamic efficiency ratio near 3.0. For each unit of drag created, they produce roughly 3 units of downward force. Attaining that level demanded half a century of racing development, substantial research funding, and some of the sharpest minds in the field. It stood as the practical ceiling, a benchmark many thought could not be exceeded without fundamental redesigns in vehicle structure. The Xiaomi Vision GT reaches a ratio of 4.1. Consider that carefully. A company that began by selling accessible smartphones has entered the pinnacle of automotive engineering and delivered a figure once deemed unattainable. The approach they took makes the achievement particularly notable, drawing lessons from the skies. Instead of examining other road vehicles for guidance, Xiaomi's engineers looked upward. To understand their method, consider a stealth bomber. These aircraft lack prominent vertical stabilizers or large tail structures. Their overall form appears broad and flattened, almost like a manta ray gliding through the air. This design serves a clear purpose. The entire airframe manages airflow without depending on separate external elements. The body itself generates the required aerodynamic effects. Xiaomi's team studied this principle and asked a direct yet daring question. What if we reversed the idea? Instead of shaping a body to create lift like an airplane, what if every contour worked to press the vehicle downward? What if the complete structure, from front to rear, produced stability through its form alone? This inverted lifting body approach forms the foundation of the Vision GT's engineering. The passenger area sits somewhat separated between the forward and rear portions. Rather than resting on a continuous solid body, the cabin appears suspended, forming carefully shaped channels beneath the vehicle. As air rushes through these narrow passages at speed, pressure drops underneath while staying higher above. This pressure difference generates powerful suction that draws the car toward the pavement. The effect draws on the Bernoulli principle, much like 2 sheets of paper pulling together when air flows between them. The faster the vehicle moves, the stronger this downward force becomes. Unlike conventional wings, this method avoids significant drag penalties. The body directs airflow efficiently rather than blocking it. The car slices through the atmosphere while using that same airflow to sustain grip. No external wing needed. No added resistance, just intelligent shaping that provides both velocity and stability. The refinements that push the boundaries further. Creating downforce through overall form is clever, but it introduces fresh challenges. During high-speed cornering, side airflow can interfere with the carefully managed underbody pressure. Even minor disruptions can diminish traction. At speeds above 150 mph, the margin between control and loss narrows sharply. Xiaomi tackled this with solutions as considered as the core design. A central vertical stabilizer runs along the car's midline, acting like a boat's keel. It maintains organized airflow even when crosswinds push from the side. Without it, turbulence could disturb the low-pressure zone during turns. Additional active features include subtle vents in the rear lighting area that direct air in precise patterns. These form an invisible barrier of airflow around the back, preventing disturbances from affecting stability. Even the wheels play a role. At first glance, they feature disc-like covers, similar to endurance racers. Closer examination reveals internal structures shaped like fans. As they rotate, they draw cool air toward the brakes while expelling heat, all without disrupting external airflow. Each wheel handles dual tasks, cooling components and supporting aerodynamics, accomplished passively without additional motors or systems. Every part works in harmony toward the same goal: consistent, efficient high-speed stability without conventional additions. This integrated method reveals a team applying systems-level thinking, typically reserved for aerospace to automotive design. Strength where it matters most. Outstanding aerodynamics mean little if the structure cannot handle the stresses involved. Speed without structural integrity is not engineering, it is risk. Xiaomi's work in the SU7 Ultra platform proves equally important. Most production cars use one or two primary load paths in crashes. Impact energy travels through limited routes before reaching safety structures. At extreme speeds or awkward angles, those paths can overload. The SU7 Ultra employs three distinct load paths. Frontal impacts distribute energy simultaneously upward through suspension towers, rearward along main beams, and downward via the subframe. Force spreads across multiple routes, preventing concentration that could compromise the cabin. The materials raise this higher. Ultra-high-strength steel with 2200 megapascals yields strength forms critical areas. Standard automotive high-strength steel typically ranges from 500 to 600 megapascals. Even structural steel in buildings reaches only about 250 megapascals. The safety cell in this vehicle uses material nearly 9 times stronger than what supports many modern structures. Door pillars, roof rails, and surrounding framework create a continuous protective structure. This design exceeds standard crash requirements by roughly 20% in impact speed tolerance. Since energy increases with the square of velocity, that margin allows the structure to absorb over 40% more force while keeping the passenger cell intact. Doors remain operable. The roof stays in place. Occupants have a much higher chance of walking away. Protection where it counts. Electric vehicles face unique challenges with their battery packs. These systems store tremendous energy. Under normal operation, it releases controllably. But puncture or damage at speed can trigger thermal runaway, where temperatures spike rapidly and reactions become self-sustaining. Many manufacturers add thicker underbody plates for protection. But this increases weight and reduces efficiency. Xiaomi approached the challenge from multiple angles. A honeycomb aluminum structure surrounds the pack, designed to absorb and dissipate side impacts by deforming. A reinforced front beam intercepts road debris before it reaches vulnerable areas. Most notably, the underside features a specialized ballistic grade coating similar to materials used in protective armor. Testing with high-velocity projectiles showed the pack remained intact. Even in deliberate failure scenarios under extreme conditions, the thermal system managed heat safely without catastrophic results. Putting it all to the test. Does this engineering deliver in practice? The Nürburgring Nordschleife spans 20.8 kilometers of demanding terrain with over 170 corners, significant elevation changes, and constantly varying surfaces. It serves as the ultimate proving ground for performance vehicles. Every serious manufacturer uses lap times here to validate real-world capability. The production Xiaomi SU7 Ultra completed the circuit in 7 minutes and 957 seconds, making it the quickest production electric vehicle ever recorded there. It outperformed the Rimac Nevera, a purpose-built hypercar designed specifically for record attempts. A prototype version went further, achieving 6 minutes and 22.091 seconds, placing it among the fastest cars in the track's history. Note that the Vision GT itself remains a concept developed in collaboration with Sony for the Gran Turismo 7 game series. It will not reach showrooms. Its 4.1 efficiency ratio comes from advanced simulations rather than physical testing. Simulations provide powerful insights, but differ from real-world conditions. Still, the Vision GT represents clear engineering direction, demonstrating what this team understands and where they aim to go. That vision already appears in production vehicles like the SU7 Ultra, where lap records are verified and safety innovations are independently tested. Xiaomi has shown that expertise for world-class performance cars no longer belongs exclusively to legacy manufacturers with motorsport heritage. A company rooted in consumer electronics has entered this arena and expanded what seems possible. Traditional rear wings may persist on some models, but the assumption that they are required for top performance has been challenged. The thinking behind both the Vision GT and SU7 Ultra points toward exciting developments ahead. The coming years in high-performance automotive design promise innovations unlike anything seen before. If this left you as impressed as it did us, give it a like and subscribe for more. Turn on notifications so you catch future updates. The pace of progress here is remarkable, and there is much more to come. One final question for the comments. If Xiaomi eventually produces a road-going version of the Vision GT in the next few years, how do you think traditional European manufacturers would respond? Share your thoughts below.